Okay, so what we're going to do here is look at something that often causes trouble in exams, which is how the conditions in the nucleophilic substitution reaction between amines and halogenoalkanes can affect the product. So what we're considering here is how when we take a halogenoalkane, something like chloromethane, and react it with an amine, maybe ethylamine, what products we'll get. Now we know that these two react because amines are nucleophiles, and so this can attack the carbon and substitute for the chlorine. And in a series of steps, at first the nitrogen will become positively charged because you've added it to the alkyl chain and you've lost your chlorine. But then you will be able to lose a proton in an acid-base reaction. You'll be able to lose that proton and make your product, which would be, I'm going to CH3, and then an N with one H. So we've gone from a primary amine to a secondary amine. So that's how halogenoalkanes react with amines. But what product you get, whether you would get this secondary amine, would depend on the conditions. Now, you would get the secondary amine if the amine was in excess. But if the halogenoalkane was in excess, then you're going to get a different product altogether. So let's just take a look at the excess of the different things and see which product we're going to end up with. So first of all, let's have a look if we have excess amine. So if we have excess amine, then we are going to essentially, you can think of it this way around, it's sometimes a bit easier to visualise, we're going to essentially swap one of the H's of our amine for our halogenoalkane R group. So if we had swapped this, if you imagine, now that's going to swap out, we're going to get our amine, what has one less H and one more R group, and that R group came from our halogenoalkane, and we've got HX, excess amine. So what are our different possibilities? Well, if we have excess ammonia, so if we start with NH3 in excess and we swap, we're going to end up with a primary amine. We're going to have an R group for where one of the H's were. If we start with a primary amine in excess, then we're going to end up with a secondary amine because we're going to end up with two R groups. We're going to swap out another H, and if we have excess secondary amine, we're going to end up with a tertiary amine. Let's have a look at an example. Let's take an amine in excess. So we've got this amine and it's in excess, and we're going to react it with a halogenoalkane that's not in excess. So let's just have a nice simple one. Let's have CH3Cl. Now remember, if we have excess amine, we're going to swap, so that's our amine here, we're going to swap one of these H's for the R group of the halogenoalkane. So I'm just going to do that. I'm going to remove that and take that out, and I'm going to put on, in fact I'm going to change colour, I'm going to put on the chain from the halogenoalkane. And if we have excess amine, that is where the reaction would stop. So let's have a look at another one. So if we take a different halogenoalkane that's maybe a little bit more complicated, so 2-chloropropane, and had excess, let's have methylamine even. Let's have methylamine. Then remember that we look at our amine structure, which is methylamine. We're going to replace one of the H's with the R group of our halogenoalkane. Now, because this is connected to the halogen in the middle, it's going to be connected here in the middle, so that C is going to be the one that had the Cl, because that's what's been lost. And we'd end up with a structure like this. Excess amine. Okay, so one of the H's off the amine disappears and we end up with the chain from the halogenoalkane instead. Okay, so what if we change it round then? What if we say we had excess halogenoalkane? What we have to know here is if you have excess halogenoalkane, you're going to make what we call the quaternary ammonium salt. And the quaternary ammonium salt is when you have an N, and instead of having 3 bonds like N normally does, it's going to have 4 bonds, and these are going to be all R groups. They're probably going to be different things. They might be the same, but they're not necessarily going to be the same, and a positive charge. And then there'll be a negative ion that will have come from the halogenoalkane. Let's have a go at an example. So if I said, back to the beginning, we had a nice little amine, ethylamine, and excess chloromethate. So this time, because it's excess halogenoalkane, what we're going to do is have 4 sticks and a plus. Now we can't change the fact that it was ethylamine, so we've still got that ethyl group, but now because it was excess halogenoalkane, we're going to have 4 sticks, and those 4 sticks have to contain the R group of the halogenoalkane. So in this case, it's a methyl group, so we've got 3 lots of methyl groups, and because it was a chloroalkane, the counter ion is going to be a chloride ion. What if we start with a secondary amine? What difference would that make? So if I were to start with dimethylamine that looks like that, and add excess 1-chloropropane, so do a dimeskeletal, it would look like that. Well, how would that be? So remember that because we've got excess halogenoalkane, we're going to form a quaternary ammonium salt. So we've got an N with a plus and 4 sticks. Now our N already had 2 methyl groups, so they're already there, we can't do anything about that. And now we've got to connect this chain, this propyl chain of our halogenoalkane to the remaining sticks. Now propyl is 3, so if you want to take it out of skeletal, that'd be CH2, CH2, CH3. And it would be on both sticks. Excess halogenoalkane, we swap until we get an N with 4 sticks and a plus charge. And there would be a counter ion of a Cl-. You might see the question slightly differently in an exam. So maybe you see a structure like this. It might ask you what this is. You say a quaternary ammonium ion or a quaternary ammonium salt. You're looking like that. And it would say, name the conditions and the reagents used to form this from phenylamine. So if the question told you were starting with phenylamine and it asks you for the reagents and conditions, what you need to identify is the phenylamine part is this part, isn't it? This bit. This is our phenylamine part that was here. So these other bits must be coming from our halogenoalkane. So our halogenoalkane has got a CH3. Now the counter ion is a Cl, so it's also got a Cl. And that Cl is attached to the C of the CH3. So we write CH3Cl, but if we were to draw it out, we would have 3 H's and the Cl is attached. And it's the Cl that's being swapped for the amine group. Now to make sure we make a quaternary ammonium salt, then the condition must have been excess of our particular halogenoalkane here, CH3Cl. So that's just a different way around. So what do we need to know? What do we need to remember? Excess amine, swap 1H for the alkyl chain of the halogenoalkane. But if we have excess halogenoalkane. We're going to go all the way to that quaternary ammonium salt, which has 4 sticks and a plus. So we just keep putting our halogenoalkane chain on without the halogen until all the sticks are full. So hopefully that will help you choose the right product for your reaction.